Hi students, welcome to the video lectures of software engineering. So today we are going to talk about scenario based modeling. Okay. So scenario based modeling describes the system from the user's perspective. It focuses on use cases, user stories and workflows that define how a system should behave under specific situations. So it helps developers and stakeholders visualize the functional behavior of the system. And what are the elements of scenario based models? So we'll see various elements that fall under scenario based model. Okay. Those are actors, use cases, scenarios, and interactions. Okay. So scenario based modeling will describe the system from user's perspective. Okay. So why we need to use scenario based model? Okay, so as specified, it describes the system from user's perspective. So it also helps to identify the missing or ambiguous functionalities, and it assists in validating the system through real world interactions and makes the requirements more practical and user centric. Clear? And one more important point is it bridges the communication between the technical and non-technical stakeholders. That is an important point under scenario-based modeling. So when we say the elements of scenario-based model, here you can see we have actors, use cases, scenarios, and interactions, right? So what are actors? So these are entities. So we just represent the user or customer or any other, right, using these actors. So where these entities would be interacting with the system. Okay. Use case are actions the actor performs with the system. Okay. Then scenarios are step-by-step descriptions of interaction between actors and system. Okay. Then interactions are visualized through what? UML diagrams. Okay. Example, use case, activity, sequence, etc. Okay. Right. Then use case model. So a use case is defined as a set of sequence of actions performed by an actor to obtain a specific output. Got it? That is what is called as use case. So basically it shows who interact with the system and what they do with the system. Got the point? So that is what is use case means. Let us say we have a food delivery application, right? Where the use case may be like this, like placing the order or tracking the order, making the payment, something like that, where a user is interacting with the system to do these particular operations. Clear? So then what are the key components? Actors, use cases, and relationships. These are the key components of use case model. So let us say, for example, actor. So let us say customer can be an actor. Okay. So use case can be like to place the order or to make the payment, something like that. Relationship is, what is relationship? So it shows like what the person is doing. Okay. a specific action between the actor and use case. So these are the notations. This is actor, use case, and system mode. So now you can see as a sample or use case diagram which is shown. So this is about an ATM. Okay, use case diagram for an ATM. You can see the actors, customer, and ATM technician. The customer can check the balance, deposit funds, withdraw cash, and transfer the funds. Where ATM technician can maintenance and repair. See, here is the bank. Then next is activity diagrams, right? So what is activity diagram? The UML activity diagram supplements the use case by providing graphical representation of flow of interaction within a specific scenario. Understood? So this is used to model logic and decision making flows. So the name itself will reveal you activity diagram, that is the actions of the activity. Okay. Now we can see these are various notations which we use in the activity diagram. So let us see, this is called as guard. Okay, guard is nothing but this is a kind of condition that must be true for control to flow along a path. And the second one we call this as fork. Okay, so this fork will split a single flow into multiple flows. This is join. So join will synchronize. Okay, so join will synchronize multiple incoming flows into one. Then next is merge. So this combines multiple alternative flows. Okay, this combines multiple alternative flows into one. Next one is time event. Okay, so this represents a trigger. Okay, based on some time, how much time does it passed. Okay, then this is control flow we call, where it indicates the sequence of execution. Okay, between what actions are being performed. Then this is the initial state. We call this as a starting point for the entire workflow. So this is called as final state, which means the end of the complete activity is represented by this diagram. Then this is the decision node. Okay, so where the flow will proceed based upon the condition, whether it is true or false. Next, we call this as swim lane. So this will, divide the activities based on roles or responsibilities. Okay. Then this is activity state, we say, where this represents some specific action or some specific task within the workflow. Right. These are all various notations which we use in activity diagram. This is the sample activity diagram. So as we have seen earlier, this is the starting point. This is the end. Okay. This is the end and this is start. Okay, so you can see we are checking the account. If this is withdrawal, this is for deposit. Here it's checking. Then withdrawal is not allowed if the funds are not there, and if the condition is yes. So let's say the condition is like having the funds, withdrawing the amount, then update the account balance. Okay, this is a sample activity diagram for banking system. Got it? So, students, hope you got this. Okay, this is about activity diagram, we say. Okay, activity diagram always will represent the workflows or sequences of activities, and this will be used to model some logic or decision making flows, as you can see here. Clear? And done. Next is sequence diagram. Okay, what is the sequence diagram? So sequence diagram is a type of interaction diagram that shows how objects interact in a given scenario of a use case. Okay. What are the key elements? Actors and objects, lifelines, activation bars, messages, synchronous and asynchronous. What are these? So when I say actors and objects, which will represent the users and system components. So actor is like the user, object is some system component. Clear? So these will interact, how they interact with the sequence. Then it's lifeline. Okay, lifelines are like, these are some vertical dashed lines. Okay, vertical dashed lines, which will, represent, or which will show you the existence of an actor or an object. Okay. So next one is activation bar, we say. So this is a rectangle on the lifelines, which will indicate the time span. Okay. So I'll show you, like it will be there in this bit. Okay. Next one is messages. Yes, these are some kind of, arrows. Messages are arrows between the lifelines, okay, which represents there is some communication that is happening between the actors and objects. Next is synchronous and asynchronous. Where synchronous is where the sender will wait for a response, and asynchronous is the sender will proceed without waiting. Okay, so this synchronous is represented with some, solid arrow head, and this is represented as open arrowhead, the head of the arrow. Okay, so this is a sample sequence diagram, you can see. So whatever I have mentioned earlier are represented here. Okay, so this particular diagram, it is showing you an emotion based music player. Okay, where the first application will be opened by the user, and then the device then gets access to the webcam, and the webcam will capture the image of the user. Then the device uses algorithms to detect the face and predict the mood. Then it requests the database for dictionary of possible moods. Then the mode is retrieved from the database. Then the mode is displayed to the user, and the music is requested from the database. The playlist is generated and finally shown to the user. Okay. So these are all the sequence of operations. This is user, device, database. So here we're opening the application, accessing the webcam, getting the photo, detecting the face, and retrieving the mode, display the mode, playlist, retrieve, generate playlist. This is the sequence. Hope you understood, students. So then we have the benefits of scenario-based modeling. So this encourages active user involvement, absolutely, and improves requirement clarity, helps in early detection of designer issues, supports test case generation based on user scenarios, and ensures better user experience through system validations. So these are all the benefits of scenario-based modeling. Hope you understood, students. Thank you.